Alright, I apologize for that. I had a little camera difficulty, so we're going to pick it up here on number 7. We're going to do the acceleration of a jet accelerates from rest at a rate of 15 meters per second squared over a distance of 200 meters. What's the final velocity? So, given acceleration 15 meters per second squared over a distance of 200 meters. Now, from rest again means that the initial velocity was 0. We're supposed to find VF. What is the final velocity? So you look on our equation sheet and we see we have this equation: VF squared equals VI squared plus 2A delta X. You see, most of the equations have time in them, but sometimes you don't know how long something took to change its motion. So in place of time, if you see a problem like this one where you're not given some times to deal with, but you do have a distance, this is pretty much the only tool we have to solve problems where we don't know the time that something took place in. So notice that this is squared, so in the end we will have to take the square root to get the answer. So VI was 0 squared plus 2 times the acceleration of 15 meters per second squared times the distance of 200 meters, which is 2 times 15 times 200, so 30 times 200, so this is 6,000 meters squared over second squared, and that's VF squared. So now we have to take the square root of both sides, right? Square root, and VF then is 77.5 meters per second. Number 8 is really two problems too. A ball is dropped from rest and falls freely. How fast is it falling after 3 seconds? How far would it have fallen in that time? Given a ball is dropped from rest, VI equals 0. Get in the habit of immediately identifying that when things start from rest, the initial speed or velocity is 0. It falls freely. Now, we have to talk about this, right? In free fall, the only force on a falling object in free fall is that of gravity, and the acceleration is that due to gravity. So if a thing is in free fall, if it's a problem about free fall, then you know immediately that the acceleration is equal to g, the acceleration due to gravity. It gets its own symbol, g, and the value of g is 9.8 meters per second squared down. Now, we've said this numerous times in class that you're free to choose which directions in a problem are the positive ones and the negative ones. Whatever you choose, know that the gravity, the acceleration caused by gravity here on Earth is this large, here's its magnitude, and the direction is down. For this problem, I'm going to choose that down is positive. Because it's falling from rest, it's only going to go down, and we're asked to find out how fast it's falling down and how far it will fall also down. So it's convenient for me to choose down as the positive direction for this problem. So VF equals VI plus AT. And for a free fall problem, A is the acceleration is the gravitational, is the acceleration due to gravity. VF equals 0 plus 9.8 meters per second squared. Oh, we left out a given. I apologize. T equals 3 seconds. So 3 seconds equals 29.4 meters seconds over seconds squared, cancel, cancel, 29.4 meters per second. For the distance, we need delta x equals VIT plus 1/2 AT squared. Now, we know that the initial velocity is 0, so delta x equals 0 plus 1/2. The acceleration is that caused by gravity, 9.8 meters per second squared. T is 3 seconds squared quantity, 0 plus 1/2 times 9.8 meters per second squared times 9 seconds squared. And you do the math, and you find that after 3 seconds, this thing has fallen 1/2 times 9.8 meters per second squared times 81. Oh, I'm sorry, we already did that step. Times 9 seconds squared, and you get 9 times this, divide by 2, for 44.1 meters. Thank you for watching.